All right. Hello, and what we're going to talk about in this tutorial is how to solve for logarithmic graphs, how to sketch them, how to find their asymptotes and x-intercept, and then also determine their domain range. Whenever you do a logarithm, you have to understand a logarithm is the inverse of an exponential of an expo. If you know a lot about exponentials, basically everything is going to be the opposite of that, or this juxtaposition of that. Not necessarily opposite where it's going to be negative, but it's going to be the switcheroo. Let's call it that. So when you have log base b of x, let's just say that equals y, our graph of this basic standard logarithm is going to have some key properties. Because it's the inverse of a exponential, exponentials, if you look at the other tutorials, we know that they have a horizontal asymptote. However, since this is the inverse, a log doesn't have a horizontal asymptote. It actually has a vertical asymptote, and it's going to have one at x equaling 0. Now, exponentials also have a y-intercept at 0, 1. Well, a log, since it's the inverse, will have an x-intercept right here of 1, 0. All right, 1, 0 for a basic one, because the log base b of 1 equals 0, and that's the reason why we have that. And also, exponentials grow really fast, while logarithms are the antithesis of this because they grow really slow, like so. All right. So, using this knowledge of our basic exponential has a logarithm has vertical asymptote and an x-intercept, we're going to use that information to help us sketch the graph of these two different equations, these two functions. So the first one, we're going to graph this one, and we're going to determine some key features of it. Well, what's happening here is we are taking this graph, and it is moving to the right 3 units. Now, this is a natural log, just so everyone knows, a natural log, whenever you have ln of x, or whatever that is, that means it's log base e of x, log base e of x. So there's a base of e here, even though it's not shown. So we are going to the right 3. That's a transformation. We also know that this graph, that's somewhere here, is going to go to, it's going to go up 2, okay? Now, this is not a 6, this is a b. And what we're going to do is we're going to take this one, which all logarithms basically generally look the same way, and we're going to move this to the right 3 up 2, and then finally we're going to reflect this over the x-axis. All right, so let's do this. We're going to then start right here. We know that our vertical asymptote, we're going to reflect over the x-axis, it doesn't go anywhere. We'll move it up 2, it just stays still at 0. But now we're going to move to right 3. Well, now instead of being at 0, it's actually going to be over here to the right here, of 3. Okay, we got the right 3. So it's going to be x equals 3 is going to be that, all right, vertical asymptote. Now our x-intercept, which is originally here, it's also going to move to the right 1, 2, 3, but it's going to be reflected first, which doesn't really move it, and then moves up 2. So this new point, this new junction point, where the graph kind of changes and starts to increase a little bit faster, is going to be right here at 4, 2, 4, 2. Now, our graph now originally looks like this. However, it's been reflected over the x-axis. So that means instead of being an increasing logarithm, it's actually going to be a decreasing logarithm looking like that. Okay? All right, well, let's find out our different things that we're looking for. We found that we have a vertical asymptote, so that's all the asymptotes we got. But now let's find our x-intercept. Now the x-intercept, unlike its partner, the y-intercept, x-intercepts are finding the x value. Now how do you find the x value? Well, it's when the y value equals 0. So we're going to make this, since f of x equals y, we're going to make this equal to 0. We're going to solve it. Use algebra. We're going to solve this one right here. So when we do this, I'm going to give myself a little bit more room. We're going to subtract 2 equals negative natural log of x minus 3. So that's really important that you know how to do this. Divide by negative, so we have 2, so make sure you're good with your algebra. And now we get to our log. Now, how do you solve for a logarithm? You do the inverse operation. What's the inverse operation? It's an, well, exponent, all right? So what we're going to do is going to base this of base e, because that's what that is. When we do that, the inverse operation, e to the natural log, we know a function composed of the inverse equals the value inside. Hopefully you know that. These cancel out. We have x minus 3, and that's going to equal e to the e squared. We're then going to add 3 to the other side, and we can see that e squared plus 3, and that seems right because it's going to keep on growing, and way down here, probably about 7-ish, somewhere around there, 7, 8, 9-ish, somewhere around there, we're going to have a x-intercept, but I'm not going to label that just because it's a little bit farther down, and I'm just doing a little sketch. All right, so we found our x-intercept. All right, and this is the point, just so you know, x equals this, y equals 0. All right, y equals 0, so that's our point. But we're not done yet. We also want to figure out what is our domain and range. Well, the domain, you can see, is what x values we're using. Well, we're not using any values less than 3, so we're only using x values which are greater than 3. Our range, well, since it's a vertical asymptote, it goes up all the way here, but also this increases, all right, all the way down to negative infinity. So essentially, this is all real numbers. It's the opposite of what an exponential graph would be. And I think we just answered the questions. So here's a log. Here's a sketch of the graph using transformations. We found its vertical asymptote and the x-intercept, and then identify the domain and range. All right. Well, I think we have time. If you want to stop, you can maybe fast forward and find the answer to this one, or you can try it out. But I'm going to do this one real quick. And let's start with this one. We have a log base 5, so base b, all right, looks similar to this. But this one is going to the left one, and this is also moving down 2, down 2. So what is happening to this graph? Well, first off, let's look at the vertical asymptote. The vertical asymptote, which starts at 0 originally, because that's what the original function does, all right, um, is moving to left 1. So that means it's moving left 1 and then down 2. Well, it's just a vertical asymptote, so we're just going to have this right here. All right, I'm going to have x equaling negative 1. That's our vertical asymptote. Now, where is this, all right, 1 point going? Well, we have this moving to the left 1, so it's at 0, 0. But now it's moving down 2 there. So I guess it turns into a y-intercept. And there's no reflections, so it's going to still be increasing, but we're going to have something that looks like that. And that's our graph. We have our horizontal asymptote right here. Sorry, our vertical asymptote there. Let's find our x-intercept. Remember, the x-intercept is when y equals 0. All right, so let's find that out. We have 0 equals log base 5. That's a little bit nicer number to deal with. I'm running out of room here. Minus 2. I'll squeeze that in there. All right, and we're going to add the 2 to the other side. 2 equals log base 5 of x plus 1. From here, we got to get rid of this log. How do you get rid of log? Let's do the exponential. All right, exponentiate both sides. What happens if we use the inverse property? These cancel out. We're left with x plus 1, the value inside. We have 5 squared, which is 25. And now we're going to subtract 1. So we have 24 equals x. And you can see that this would keep on growing very slowly until it got to 24. So that's our x-intercept point, x equaling 24. Y is obviously going to equal 0. That's our point, x-intercept. And now let's find out our domain and range. The domain of this function, looking at it, we can identify that the vertical asymptote, so start there, and all our x values are going to be greater than, it appears to be -1. Our range, once again, goes all the way down to -infinity, and this will keep on increasing to infinity. So we have all real numbers here, and we just graphed two logarithms. So I hope this helps you out in graphing logarithms. Key things with logarithms. Their inverse is exponential. That means then they have a vertical asymptote and an x-intercept. They're guaranteed to have one. The domain, all right, is associated with the vertical asymptote, and you can find this vertical asymptote by looking at wherever the horizontal shift is, which is inside the log. And I will tell you where it's going to be located. I hope this helps you out. Good luck and God bless in the rest of your problems.